I'm Dayna, a graduate student at the University of Waterloo, and I'm here to tell you about my research on printing integrated manufacturing.
Recent advances in printing technology have made printing available in home and office environments, from high-quality photographic images to the quick output of text documents. Now, manufacturing equipment like this flatbed router here can machine materials like wood and metal into products such as furniture and signs. Typically, when you want to paint, pattern, or add a coating to these products, you would have to move the material from one machine to another separate machine, which means wasted time, added cost for the extra machine, positioning errors as a result of moving the material from one machine to another, and possibly needless manpower to monitor and operate the process. The idea behind printing integrated manufacturing is that these two processes, coating and machining, are combined into one system. What makes these two processes so compatible is that they are both heavily dependent on the positioning accuracy of the machine. A printer works by printing one swath at a time. The number of nozzles in a printhead determines the thickness of the swath and also the resolution in dots per inch. One printhead has 126 nozzles over a distance of 10.3 millimeters, angled at 36.89 degrees, and the result is a resolution of 309 dpi. This implies a required accuracy of 82.2 micrometers or less. If even one of those swaths are misaligned, you get a bad image. Similarly, you can imagine that machining with poor accuracy would lead to rough or distorted surfaces. Thus, positioning accuracy is extremely important because the human eye is very good at picking out any discrepancies in an image. Higher positioning accuracy means a desirable product that the consumer is happy with. The idea of integrating printing with manufacturing is not new. For example, there are flatbed printing systems that can print on large sheets of paper or textiles and cut them into several smaller sheets for mass production. However, the goal of this research is to improve the results of current technology and also focuses on machining of materials such as wood and metal. So far, this research has shown the feasibility of installing an inkjet printing system onto a flatbed router. We are currently working on improving the positioning accuracy by developing the motion controller and identification methods to determine the higher order dynamic properties of the machine and increase the bandwidth. Let's look at the actual integration. These bottles provide the ink for the printheads. Filters remove any particles from the ink, and the pumps carry the ink from the bottles to the header tanks above the printheads. The header tanks make sure there is enough ink available for the printheads based on readings from their pressure sensors. A controller ensures a meniscus of ink is maintained at the bottom of the printheads. Ink is sprayed from the printheads based on image information that is sent from the software. The motion controller is developed in MATLAB, a computational programming software, along with its modeling software, Simulink. A real-time program manually controls the position of the printheads so that they can be homed to a specific position every time the program is run. Once it is in home position, the printing can begin. The printheads move into position 1 millimeter above the substrate. It moves at 250 millimeters per second across the material with an accuracy within 60 micrometers. A product detect signal is sent to the printing software to indicate where to start each swath of print. Position signals from the encoders determine how quickly the printhead should fire. Currently, the best results have been achieved by unidirectional printing, but research is being done on bidirectional printing, which would be even faster. Once it is finished, the printheads return to their home position, and what's left is the desired image. So you can see, the integration between printing and manufacturing is quite complex, because it requires the knowledge of various fields, such as mechanical design, controls, microfluidics, electrical, programming, and graphics. By integrating printing and machining, low-cost, easy-to-machine, readily available wood, or recycled wood, could take on the appearance of wood from trees that are scarce or expensive to harvest, thereby saving valuable resources. Also, photographic, custom-designed images or labels could be printed onto furniture or signs. With further research, the system could be modified for metal deposition to create products such as LEDs, circuit boards, flat-screen displays, and perform photoresist deposition and 3D cutting and printing operations.
Well, that's all the time I have, so thanks for listening and hope you enjoyed my video.